It's good to be here in the US. It's the first sort of bigger talk I've done over here, normally over in England, so hopefully we'll have no language barriers where I say router instead of router. I've been working with Angular about a year and a half now. We've done some pretty cool projects with it. It's kind of my weapon of choice. Today is not very, very heavy on Angular. We got a bit of a story to tell, starting right back from 1994 until today. So we'll take you on a bit of a journey. A little bit about me. So I'm a GDE, which is a Google Developer Expert. The microphone keeps going in and out. There's about 120 GDEs worldwide, so it's really good to be part of the kind of Google circle. We do lots of cool stuff throughout the UK. Yet to come over here yet. If there's any questions that we don't do here, feel free to catch me online on @ToddMotto on Twitter. I'm on GitHub and stuff as well. So today we're going to have a look at the web very, very far back when I was 4 years old. So this is kind of the outline for today. Yesterday, where we came from. We'll look at tomorrow, where we're headed. One of the things that I'm quite passionate about is how Angular is not just a framework that somebody thought was a good idea. They're actually building a framework that's kind of looking ahead. So they'll say, oh, we've got these great APIs, let's try and deliver them to the user now. There's things like web components, kind of inspired the way that Angular do quite a few things. So we'll look at also today what's available in the browsers. Angular today, and there was a couple of people who asked about Angular 2.0 at the workshop yesterday. They're doing a huge sort of rewrite in ES6, which is a brand new JavaScript language, which isn't very in the browser yet. So we'll look at all that and hopefully go away with some cool information. So before we get going, I want to rewind, go right back to the typewriter age where there was no machines. So everybody recognizes these, emphasis on the capital letters. You still see sites like these nowadays. And we used to use tables before the divs came about, and layouts were very heavily table-driven. Brings back bad memories for me. It probably does quite a lot of people as well. Some of the favorites, we got the blink tag, the marquee tag. Is anybody still using these? Yeah, 5 of you over there. The center, this one seems to be still sneaking around on the web. I'm not sure why. Font size 4, if you think how CSS has come so far in the last couple of years, we don't need to do all this declarative stuff. You find that the old web is very attribute-based, and we're doing a lot of manual work. Even more hideous, we had JavaScript in our hrefs. We've even got some www1, which used to be cool. And I think everybody's favorite is the map. And what all these amazing technologies gave us back then was something a little bit like this, which was Microsoft's first website in 1994. So we've come a long way. You can actually, if you go on Google and type in Microsoft's first website, this page is actually live. The links don't actually go to the pages that they were going to, but you can still see how it was built, and there's some interesting code underneath it. So this was 1994. 11 years later, hopefully my math's correct, we reached YouTube in 2005. So not a lot changed. This looks like some kind of Dreamweaver template. A little bit embarrassing if you started YouTube and looking back on this. Sorry if there's anyone in here. So where are we now? We've got some more digital stuff. HTML5. So this was, when we think about HTML4 and the old tables and that kind of stuff, you can feel that we've come a long, long way. So we'll rattle through some HTML5 APIs and some of the elements really quickly. So we've got video and audio. These are now native. We used to use sort of Flash-based systems for this. We've got WebGL, Canvas, where we can draw things in the browser now. Get user media, so we don't have to use Flash-based plugins again. We can request audio access. We can request the user's webcam. Geolocation, I've put kinda. It actually was supported in IE8, so it's not really an HTML5 API, but it kind of sits under that umbrella slightly. The full screen API, which sadly I'm not demoing now because this isn't in Chrome. We've got WebSockets, so we can have a stream straight to the back end. Local and session storage, so these are quite a cool API. Where you can save stuff to the browser. It can be destroyed after the session, or you can persist it locally. So when the user comes back, they might have information that they've typed into a form that's still there. We got the history API, IndexedDB, WebSQL, another kinda. Native form validation, which for me is a slight headache. It's very inconsistent across browsers. The form data API, if you're dealing with forms, is a really, really nice API. We've got dataset. So we saw custom data attributes coming into the web. We've now got a JavaScript API called dataset where we can actually talk to these attributes and edit the data inside them. We got the semantics, so we got new elements, header, section, all of these new HTML tags. The file and file reader API. Recently built a file upload component which made use of this, and to do it supporting sort of the older IE browsers, you have to create like an iframe and post to it, and it's very, very nasty. So these new APIs are making our lives a lot easier. The class list API, there was a lot of JavaScript libraries such as jQuery that actually kind of inspired some of these. So we've now got native add classes, remove classes, and toggle classes. We've got the drag and drop components, so we can actually have draggable elements. Post message, so we can communicate across domains, and the content editable attribute. And breathe. HTML5 is pretty big, and looking back at the tables, I think we've come a long, long way in such a very, very short time. If you think in 2005, the YouTube site, we didn't really have a lot of this stuff. So, and it's escalating at a crazy rate, and it is quite scary to think about how quickly the web is going. So, as if that wasn't more difficult enough to keep track of everything, we now got frameworks. So model view, whatever. Who here is using a MVC or MVVM framework? So yeah, good percentage. Okay. So if I typically came from building websites, so I build web applications now. And the transition from using like a JavaScript library for manipulating the DOM to using a JavaScript framework is absolutely huge. You've got to change your thinking, and you're building sort of single-page AJAX applications with a lot of JavaScript. Some might say that's a good thing or a bad thing. So in no particular order, but I'll put Angular at the top because it's the best. We've got Angular. Hopefully everyone's... Who here is not using Angular? Everybody? Okay. 10 people-ish. Okay. So we got Backbone as well. We've got Ember and Knockout. I previously started looking at Knockout.js, and then somebody nudged me on the way to Angular. I was like, yeah, fell in love with it. We got also React, which is slightly different. It's more the V in the MVC. So why do we need these frameworks? Why aren't we just using all the native APIs? We're still missing things. So more importantly, the web is very static at times. Until we add some dynamic stuff like JavaScript, we need templates, we need encapsulation and components. And we're addressing these things in things like web components, HTML5. Two-way data binding. One of the things that Angular uses heavily is something called digest cycle. So it allows you to, if a user changes something, it's persisting the model changes that the user makes. If the backend then fetches more information, it's keeping all the data in sync so the user can see everything that's coming in. We've got promises, class-like components. React actually uses, they call it create a class. I think Backbone uses a similar style, so you can create classes. We've got promises. Angular uses an HTTP service which can return promises. It uses something called $Q, which is a promise implementation. Modules, so Angular's quite a modular framework in the way that you can build all these different modules and then import them into a single module. And dependency injection. I love the way Angular does dependency injection. I think they're going to be changing it in 2.0, but we'll have a look at that in a bit. So where are we going? Web components. It's quite interesting because Google are actually pushing, I think they're pushing web components quite heavily. And who here has used Polymer? Not a lot of people. Nobody's using it in production yet, which is quite interesting. Polymer is basically a polyfill for this upcoming web component spec. And what it allows us to do is think in terms of all these encapsulation, all of these components, and use them now. We've got object.observe, which is actually ES7, so ES6 hasn't even arrived properly yet, and we're already thinking and using these stuff from ES7. Object.observe allows us to, in a way that scope.watch works, it allows us to natively look at model changes to JavaScript objects, which is very, very, very fast. We've got native promises, so we kind of decided that was a good thing. We'll look at some code snippets for this. And we've got modules, ES6 modules will have also some code snippets. And ES6 classes, there's a kind of a decision where a lot of people think classes are a good thing or they think it's a bad thing, but I'm sort of in the middle, I'm not sure yet. So, custom elements. This is kind of what they look like. So the whole idea and the selling point of these is that if you want to make things more readable, more semantic, and to keep things sort of very testable, like you can have a Google Map element, for instance, which you know is packaged, you know all the JavaScript APIs are underneath and loaded. And you see here we've got a latitude and longitude. I can just pass those in and say, I know that's going to work. And I've got another developer on my team who can import my Google Map API, the element, sorry, and the API underneath will spin up the longitude, the latitude, and if you've used the Google Map API, there's probably at least 50 lines of JavaScript which you have to actually write to actually get the hello world in your map marker. So we can think in terms of these components to make things a lot easier for ourselves. Templates. So we've got the template element. This, we give it an idea of Google Map. They actually a bit indecisive on the implementation. They actually had an element, which was recently, I think it was last year, it was deprecated. So now we use JavaScript to instantiate these new templates. If you're quite interested to note, you've got the :host. So that refers to the very root element of the template. What this allows us to do is have pure encapsulation and pure scoping. So currently, if you've got an HTML page with a load of CSS, if you were to inject another element, it just instantly inherits any styles that might already exist. What the shadow DOM and this host allows us to do is have pure scoping. So if this class, the ID here called map, if that already existed in the DOM, and we inject this shadow DOM stuff, actually allows us to have two completely separate DOMs and two completely separate styles. They don't inherit. Onto Shadow DOM. If you are a Chrome DevTools user, or I haven't used it in Firefox because I don't like the DevTools, but they actually show you the Shadow DOM. So if you're inspecting Shadow DOM, this is what you'll actually see in the browser. So as before, we declare our Google Map attribute. We've got our longitude, our latitude, and this is just a very basic assumption that it's going to parse out a couple of divs with a canvas inside and the maps generated for us. You can actually toggle this shadow root. There's a setting in Chrome DevTools where you can say, I want to see the shadow DOM. HTML imports. So there's a couple of JavaScript tools that we can use in the browser at the moment. There's things like AMD and require.js. They allow us sort of to keep our dependencies in track. Things like common.js, which we use with Node, sort of var something require this. So HTML imports is kind of that thinking, but for HTML. So once we've created our components, we need to then declare them. We need to import them. And this snippet here would lie in your head tag in the HTML. So after creating our Google Map, we would stick it in a components directory and simply import it. After that, we can just go away and start using this Google Map element. Object observe. This is, I think Chrome thought this was a really good idea and tried to implement it early. I think other vendors are actually doing the same. This is just a simple example from the HTML5 rocks. I think Adi Osmani put this together. Let's say we have a model with some data. So we've just got a normal JavaScript object here called model. And what we can do is call observe on it. Once something in that model changes, we actually get an array of changes passed to us. We can then loop through them, and we get the old value, the name of the change, and some other stuff that actually helps us build applications. ES6 promises. So we looked at, this will be familiar to a lot of people, the promise API. If you've used other JavaScript libraries, they usually use this .then syntax. So we have a variable at the top called promise. We call new promise on it, and we can make sure that if everything's okay, we can resolve that promise. If it's not okay, we can reject it and throw an error. And you'll see here, if my mouse is there, yeah. So we can then call then. So this is actually calling our promise. If things have worked out fine, we get a nice result, and we can see that stuff worked. If we don't, we get an error saying it broke. ES6 modules. This is quite an interesting one. I read something recently where people were saying, I love the ES6 modules, but I'm using the browserify or common JS pattern in the browser, and I kind of prefer it to this. So it'd be interesting to see where this goes. This is actually the final specification, which was very timely. It came about a week before the previously gave this talk. What it allows you to do is export particular variables or functions from a file. So we got lib.js at the top here. And what we can do in main.js underneath, you see we got import, square, and diag. Should have called that diag something else. It's not very hard to read, not very easy to read. And then we've got from lib. So that just assumes that it's called lib.js. So we can import these dependencies natively now in JavaScript and start using them. We don't have to worry about the order of the order in which the files are loaded. If you're using browserify, well, actually, if you're using Angular, you have to create your initial module first, and then you have to make sure everything else sits underneath it. If you have your module declared at the bottom and or your files above it, it's going to throw an error saying my module app or something doesn't exist. So this is a way that we can not worry about the load order. ES6 classes. My friend Jack Franklin, he's got a blog, JavaScript Playground. This was, I helped him sort of proof this article. It was kind of my first introduction as well to ES6 classes. And it's quite scary if you've just sort of, like I came from a very jQuery-like background and started teaching myself raw JavaScript. And then you start learning more JavaScript and you're like, oh my God, I need to learn even more. So this was quite scary for me. But you can see it looks completely different to the JavaScript that we're writing today. We've got a class called model. The function word doesn't exist. It's not like a proper object. There's no colons or property names. So the to object, we can see, it just assumes that that's a function. So the bit that we've hopefully all been waiting for, where's Angular? So I wasn't just kind of rattling on about the web and where we've come for no reason. It's actually Angular overlays on this technology very, very nicely. And if you've been using Angular directives, you're going to come across things like this. So we've already created our Google map in web components. We could use Polymer if we wanted to. Angular allows us to create it now, basically. So there's a couple of ways that Angular allows us to do this. We'll come on to the API in a second. But it's basically in the exact same way as that we will be doing things in a couple of years to come. So they've got their own intelligent parsers that you can declare either a custom element like this, which doesn't work particularly brilliantly in older IE versions, but they actually give you a safety net. You can create a custom attribute instead, and it will loop through the DOM and fetch it there. So on the template side, it's slightly different to the way that Web Components does it, but it's this feeling of having something encapsulated. If there's anyone shuddering because there's a template in a string, there are other ways to do this. So here we've got a directive. So I like to keep my functions outside of the Angular framework and just simply pass them to Angular when I need them. Inside here we've got an object which is returned. And it's interesting to note the scope object, the first line. We've got longitude and latitude. So these create a local scope in the directive. The two equals signs, that says it's basically equal to equals longitude and equals latitude. But if your attribute name that you're passing it in as and the local scope are the same name, you can keep just use equals for it's like a shorthand syntax. Once those are sort of made available to you, so we get some numbers passed in from longitude, numbers passed in from latitude, we can then use a controller in this directive to then pass the data and instantiate the Google map and go ahead with our component. One of the things that's important to note with the directives, you see I've got Google and then a capital M for map. What Angular does is translate the capitals and puts a hyphen. So when we actually declare our element, it'll be Google-map. Shadow DOM in quotes here. Angular doesn't deliver a shadow DOM because it tries to go back as far as it can in terms of browser support. So we've got it in quotes because it's not very real. This is how, as you can see, we don't have the root element, the shadow DOM in the inspector. So Angular just pretends that it's doing shadow DOM. It will serve up an instance of our directive, compile it, and what it will do is inject it inside our element. We can also tell Angular to get rid of our initial element. So we've got Google map, latitude, longitude. We can actually say, as soon as you've injected it, just destroy it, which actually makes debugging slightly easier. On the HTML import side, so this is the fourth and final piece of the web component puzzle. I did say there was a different way that you could do string templates, and this is how we would do it. So we assume that there's a file, excuse me, file called googlemap.html. Interestingly, Angular allows us to do this in a couple of ways. We can actually use a script tag, override the MIME type, so that it says script type text/ng template. And what Angular will do on page load, before even the directive has been created, it loops through all your script tags and checks this MIME type. And if it does exist, it will pull it into its template cache. What it will then do is keep looking it up. So this particular way of doing an HTML import isn't necessarily a good thing. Using the script tag might be easier if you can automate that process for production. As it stands, the template URL like this, if we're not using a script tag, it's gonna know that. It's gonna go off to the server and make a get, and Google Map is going to come back to us, and then it's going to put it in the template cache. It's not great on performance if you're going to be having 100 directives and they're all going to make 100 gets. So there are ways that Angular works with us. I can't remember the specific name of the module, but if you're using Grunt or Gulp, there's I think it's called ng template cache. And what it allows you to do is develop in this exact way. So we can do template URL, we can create our components in a specific file, and what it then does is concatenates them all into its own module as strings, so they're already available there. It doesn't have to make gets. They're already sat in the template cache, so it can look them up very, very quickly. The scope.watch, I went to San Francisco last October, and they did an Angular talk there. And the creator, Mizko, he said that this actually inspired the upcoming object.observe. And the scope.watch allows us to view these model changes as strings and functions. This is what it looks like. This is just a simple controller, which I've just noticed that says directive. Pretend that says controller, please. So we get a new value and an old value passed in. It's a little bit easier of an API than looping through an array of changes and pulling out things. So it's a bit of a higher level API. Angular promises. So I mentioned the $HTTP service earlier. What we do is make a get to some URL. This is a shorthand syntax. You can actually pass in an object and call HTTP on its own. What it does is return a couple of different methods. You can use .success or .error. What I like to do is use a more standard promise-like syntax. So I'll actually use then, and the first callback will be yay, and then the second callback will be a nay with a sad face. So we get the response and the reason back. So above and beyond the specs, What does Angular give us that's really helpful that hasn't come from the web background? This is probably one of my favorite things with Angular. So dependency injection, what Angular actually does underneath is it converts every function that we use for dependency injection to a string. I actually ripped it apart, the source code, wrote an article on how it does this. It uses a couple of regular expressions. And it looks at the arguments, so it looks at scope and it looks at root scope. It pulls out any comments that we might add, reduces white space, puts them into an array for us. And if you started with Angular and then you first minified your project, everything breaks. You then have to realize that you need to actually explicitly annotate things. So when this is minified, scope's going to become A, root scope might become B. It doesn't know what A and B are. They're not like normal variables. So what we'd use is an array syntax, or we can use an inject property. What we can do is use main control, $inject. Typically that would sit straight above here. I prefer the inject syntax. In the Angular source code, it's actually the fastest way to do things. What the inject does is map the dependency names to the arguments. So we'll have an array that says $scope as a string. We'll have the next item in the array will be root scope in a string. And obviously when our code is minified, the strings don't get modified. So it knows that A and B, as long as they're in the same order as the array are, so we'll have scope and A, root scope and B, so then it will map them intelligently across for us. The dependency injection is a lot easier than trying to do our own modules. So how we would do things in the past, we would sort of make sure things are available. If not, we fall back to an object. So instead of creating a script that loads them in for us, all we do is just ask for them. You just say, I want scope, I want root scope. And the interesting thing is it doesn't matter what order you put these in. You can develop a controller with 500 lines. You can mix up all your argument names and it will just work as is. The declarative bindings. So if you're heavy on Angular, you'll be using these bindings a lot. And you can actually get away with hardly doing any work. There's some days you can go into work and write an Angular app without even writing a line of JavaScript. These bindings, they've thought ahead, they've thought a lot for us. And there's things like ng-click, which interestingly aren't like on-click functions. So if you're looking at ng-click and thinking, oh, isn't that just like the old on-click? It's completely different. They're actually scoped. So the vm.getUsers is actually only available inside the user controller, which we've got here. So this whole segment here is scoped. The other thing that we've got is things like bind. So these are other intelligent directives. Bind is just an alternative to using the handlebar syntax. So we might use that to show a value that hasn't been resolved yet. We don't want curly braces coming up on the screen before Angular's parsed the HTML and injected the data. So what we'd use is ng-bind, and the title would remain hidden. There would be no content inside the h1, and then when Angular's ready, it's going to put the content in for us. This is probably the most awesome thing in Angular, is the way it creates and destroys DOM elements. So having come from a website background where I'm painfully talking to the DOM, creating a document create element, background, li, and then injecting it back into the DOM, I might loop through the nodes, find the index. Angular makes this an absolute breeze. So if you think of this as like a navigation of some sort, instead of having like home, admin, about, or whatever you've got in your application, we can just have one list element with all the details inside, and we can feed it data. So typically we'd feed it an array of data, which it would then clone per each object in the array. And if you like writing JavaScripts and dealing with arrays and objects, you'll be used to using like array splice and push to add items, remove items. This allows us to just, if you imagine I've got 4 objects in this repeat array, it's going to give me 4 DOM nodes. If I say number 3, splice it, I don't even have to touch the DOM. Angular's two-way data binding. It will just go and remove that node for me. It makes working with applications very, very easy. And this is great for visual feedback for the user. So part of the single-page application is we don't have to refresh the page. I think the old version of Gmail, you would delete a message, and then you wouldn't actually see any feedback and you'd have to refresh the page. So now, how we would do things with Angular is I would click on my delete button, send that ID for the particular email off to the back end. The back end would say, yep, it's been deleted, and I can just remove it from the array. You don't want to remove it before, because then it might fail on the back end. So dealing with that is superb. This is also a complete lifesaver. If we do a lot of form stuff at my place, so we build a recursive directive of directives. So we've got a huge JSON object which describes how a form should be made. What we then do is give it this dynamic element, which it then parses itself and then loops back through and creates this huge object. And every single node in the JSON object maps perfectly across to this form. So there's no requerying the DOM. I don't have to go back to my input and say, give me your value. It's just there. It's parsed as a JSON object, JavaScript object, sorry. And if we're replying to an email, for example, the user hits reply, they can start typing and we just hit reply. All we do is grab that object associated with the DOM node. We don't have to worry about querying it. We can also listen to events and stuff, so we don't even have to bind our own events. The model just keeps it up to date for us. Expressions, these are, I keep saying everything's my favorite part of Angular, everything's my favorite part. So expressions are my favorite part for the moment. About a year and a half ago, we were using JSPs on the server side, so we were actually having like a hybrid application where we started to introduce Angular in small pieces. So what we would then see is conditional pieces of Java which say, if this property exists, churn out this piece of HTML, otherwise I'm going to use this bit. So what's interesting in Angular is we can completely do that on the front end. It's kind of inspired by this server-side power. So now we've got JavaScript fully on the front end. We can do this natively. We've got here user.notifications.length. So I can just assume that I've logged into Facebook or something if they were going to build it in Angular. And I can log out the length. Everything in Angular is an expression inside these curly handles. We might also swap out pieces of text. So I could have user.name or login. So I could use the double or pipe and then put login in a string. So if user.name exists, it's going to put Todd in there. If it doesn't, it's going to say login. So I can swap out these words conditionally. If you, well, we've all probably done it in the past, but you might have a DOM node like this p tag, for instance, and we might capture it in our JavaScript and say, if the user.name length exists, then the inner HTML must be this, else we'll do this. And the pain point of that is we have to keep running these functions to make things up to date. If we're going to keep checking the authorization of the user, we're going to have to rerun it and make sure that they're logged in, otherwise show them the login, the button. And Angular does this all for us. It uses a digest loop, so every single change, it will loop through everything, make sure we're still logged in, and then make sure the data associated with any changes is up to date as well. Automated events, these are also my favorite part of Angular. So inside a repeat, excuse me, we've got an ng repeat will create new scope for every single item in the array. So if you imagine, I don't know why we'd have four compose buttons, maybe someone got a bit carried away. So we got 4 compose buttons on a page, each one has their own scope. Then this compose email ng click, all we do is declare it. We don't have to painfully go and say, if add event listener supported, we'll use that, else we'll use attach event. So Angular takes care of it for us. We just tell it that we want to click event here. They have loads of other ones like double click, mouse over. Don't particularly like using the mouse over and stuff. There is a touch module as well if you're building touch mobile applications. Component lifecycles, this is a little bit of a recap. We've got the automatic event binding and unbinding. This makes our lives a lot easier. If you imagine the amount of DOM nodes that you're going to be dealing with in even a small application, you're going to be writing a lot of logic just to manipulate the DOM. So having that automatic unbinding and binding is a huge time saver. The creation and destruction of the DOM. I've also put the scope model data here. So if you're using something such as Gmail, you get that initial page render of all your messages. What Angular would do would keep those in memory. And every time, let's say you had a search box, for instance, and started typing, Angular is going to be looping through all of that data just to make sure everything's up to date. You might have a filter on the data, for instance. If you then click on the Settings tab, it injects a new page. It doesn't do a whole refresh. It just injects that Ajax content. What Angular intelligently does is destroy the model data associated with the previous view. So different views might have different sizes of data. So Angular responds quite intelligently. It's also worth noting ng-if here, more of a performance point. If you're using ng-show and ng-hide, what Angular does is actually, it keeps ng-shows and ng-hides in this huge digest loop. If you imagine you've got 1,000 items in an array that are printed out as li nodes. If you use an ng-show or an ng-hide and hide half of them, it's going to loop through all the data still. If you use an ng-if, it actually destroys the DOM node for it, so it doesn't just add a hidden class and it's still underneath in the DOM somewhere, and it'll actually destroy the data associated with it, so you're only looping through half, which keeps our digest cycles a lot faster. So still debating whether to call it routing or routing, but we'll call it routing. So this is typically how we would do it in Angular. We have it used to be baked into the core. It's called ng-root. Some of you probably use UI router. All we do is include ng-root as a module. This then gives us the root provider here. We've also got the location provider where we can turn on things like HTML5 mode if we don't want the hash bang in the URL. So here we've got, when I'm at inbox, I want the template URL. This is my view called mailbox. What Angular uses a location service that responds to the URL changes. So we can create fully dynamic views. You see the second example where we've got email and then colon ID. This IDs can be fully dynamic. If you think when you click on an email in your Gmail inbox, you get an encrypted sort of string in the URL. That changes, but the same template gets served up. So this is how we would do that kind of thing in Angular. We've got some little capture in here where we can, if the user types in something that doesn't exist, we can just keep redirecting them back to /inbox. Modular JavaScript, I mentioned this earlier. So how we used to build apps, everything used to just be one great big app. It doesn't make things very efficient when it comes to things like testing and porting assets over to new projects. So we have a form module which allows us to create all these dynamic forms. That sits as a standalone module. If we had an authorization module, we've also got Growl here, which we use for notifications, sort of an Angular Growl that's worth checking out. We can keep these as completely separate segments, and what it means is you can drag them across to new projects very, very easily. Angular makes it so easy to import them, we just give it an array of dependencies and when we're done. So what was previously just one app with all these dependencies, which made it very, very difficult to use, is now just really a joining place. So I'll have all these feature-driven modules, and I'll just bring them all together, instantiate the app, and off I go. Form validation in Angular. This is also one of my favorite things. So we've got a very, very intelligent, something called a form controller in Angular. So what it does is we give the form a name here, so auth form. Underneath it then looks at all the inputs, and we can give them things like required attributes, ng required, ng patterns. So these build on top of the HTML5 specs, but they rewrite them because the HTML5 are a bit strange. So what we get is on-the-fly modeled feedback. If the user's typing something and it needs to be 4 characters and then I don't know, four letters and 4 numbers, and they type 5 letters and 3 numbers, we can instantly get some feedback that says this is invalid. It's the ng pattern is on the fly validating it, and it's not there. Where next for Angular? Check out the bit.ly link. I highly, highly advise you to check that out. I'll give you a few seconds to write that down. They've got a huge Google Drive box with probably 50+ files in. There's design documents on the upcoming 2.0, and they do a very, very in-depth competitor analysis on frameworks such as UI Router. They're actually building the new router inspired by that. They're looking at ways to be better than other frameworks, and they also criticize themselves quite harshly. So they say, this is great in Angular, this isn't great, we need to look at these other frameworks and pinch some ideas. I'll wait for the tap-in to stop dying down. These slides will be online later if you haven't caught it. So we've got a couple of minutes left, which is good. So we've got a couple of slides left on just some stuff that's coming in 2.0. Angular Dart. So Angular Dart's, I think it's been standardized as an official language now. But they've got a change detection algorithm where it's now been ported over to JavaScript. So this is going to be inside what they call Watchtower. You can check this out on GitHub. The code's really, really interesting. Faster change detection, we're going to have a lot faster applications. One of the things that gets slow with Angular is that if you've got a huge amount of data on a page and you're making changes quickly, you start to see a lag. And they say about 2,000 bindings per page, you'll start to see things slow down. So it'll be interesting to see when this comes out, how quickly it actually is. This is what a directive might look like. So if you dig through the source code, I spoke to Brian Ford, who works on the Angular core. He gave me some brief feedback that said this is just kind of an idea. It might not look like this. I'm not really sure what this observe tabs array does. It doesn't look very clear. What is interesting, though, is shadow DOM true. So Angular are already thinking web components are going to be here by the time 2.0's coming about. I have no idea when it's coming, by the way. But we can turn it on. We can say, yeah, I want to use shadow DOM. True or false. Data persistence. This is one of my favorite docs in the Drive folder. You can actually dig through all of these and just go, wow, they're actually thinking about all these upcoming APIs. There's things like Service Worker, which like offline applications. They're actually thinking about this now. We've got ng offline, we've got $service worker. I'm really looking forward to all these. And some of these are low-level wrappers, some of are high-level wrappers. ng HTTP, so they're going to be focusing on, they're going to get rid of HTTP, I think, and resource and build sort of a more data-driven HTTP. Annotations. So you can see here that we haven't even mentioned things like Angular.module. We don't have .controller or .directive. So this is the annotations. I've put a note here, reduces the boilerplate and hides the Angular wireframe. So it makes things a little bit cleaner. It looks like actual JavaScript. And I think they're pushing for this app provide. I think it was somehow in the ES6 spec. I'm not entirely sure. Please correct me if I'm wrong. I think it was removed because they weren't too sure about it. But Angular are quite looking for this app provide annotation. If you've some of our Java guys at work, they use this sort of app get and they annotate how things work. So I think they want that in JavaScript. So this would make dependency injection a little bit smoother because they apparently don't like the way that it's currently done as much. One more slide. Takeaways from today. Love the way that Angular is forward-thinking. The Google team are really good. They're very innovative. If you check out the Drive folder, there's people on it all the time, and they're editing documents, making changes, and the amount of man-hours in those documents is probably unreal. Safe to say that frameworks are probably always going to be ahead of the web, but they help steer where we're actually going. Where next? I don't know. Maybe we'll be back in a few years and we'll find out, but we'll see you there. Thank you.